Welcome to True Projects. In this video, we are going to explain about the project that is hybrid machine learning based multi-stage framework for detection of credit card anomalies and fraud. So before getting into the execution, first let us understand what is the project about. Nowadays, with the increasing reliance on online shopping and digital payments, the credit cards have become one of the most common methods for completing transactions, that is for doing payments. So this convenience, however, it also attracts fraudulent activities and this leads to significant financial losses. That may be for individuals, it may be for merchants, and it may be for financial institutions. So these fraudsters, they continuously develop new techniques to exploit weakness in financial systems, and this makes it challenging for traditional detection methods to keep up. And the traditional rule-based systems that we have, they while they are also interpretable, they require frequent manual updates. And they also lack flexibility. And they often fail to identify emerging fraud patterns. So consequently, there is an pressing need for more advanced and adaptive approaches such as machine learning and deep learning techniques, which can effectively detect both the known and novel fraudulent transactions while improving the overall security of financial operations. And here, credit card fraud detection is particularly challenging because fraudulent transactions make up only a small fraction of all the transactions. So this leads to data imbalance. So this is highly imbalanced data, which makes it difficult for many machine learning models to correctly identify fraud as they often misclassify legitimate transactions that are genuine transactions or fail due to that is to detect actual fraudulent activities. So here, to overcome such cases, to overcome from these challenges, detection mechanisms must be intelligent, adaptive, and capable of handling class imbalance effectively. Such approaches need to continuously adapt to evolving fraud strategies to ensure the security and also reliability of financial transactions. So here the system is designed as a hybrid multi-stage framework. So this project is designed as hybrid multi-stage framework to detect credit card fraud effectively. And here the issue we had is the class imbalance. So the fraudulent transactions are far less frequent than the legitimate ones. So here we are using SMOTE, that is synthetic minority oversampling technique, to generate synthetic samples for fraud cases. This helps to balance the data set while keeping the important transaction details intact. And here, to make the models are more focused and efficient, here we perform feature selection using a percentile based method, which retains only the most relevant features. And this ensures that the classifiers learn from the most meaningful transaction attributes and reduce unnecessary noise in the data. And coming to the first stage classification, so here we have used multiple machine learning models that are logistic regression, support vector machine, random forest, XGBoost, KNN, and deep neural network. So each of these models are trained on the prepared transaction data and makes its own predictions about whether a transaction is fraudulent or legitimate. They provide confidence scores for their predictions, which helps to capture both the simple, that is linear, and complex, that is non-linear patterns in the data, improving the system's ability to detect fraud accurately. Coming to the next stage, that is the second stage. Here, the system combines the results from all the base classifiers using a stacking based meta classifier. So, this meta classifier looks at both the predictions and the confidence levels from each model, allowing it to correct mistakes and reduce false alarms. So, by layering the models in this way, the system becomes more accurate at detecting fraudulent transactions while still performing well with the genuine ones, that is, legitimate ones, providing a more secure and reliable solution for the online financial activities. So, this is what we have proposed in this project. Now, to make the system even more stronger, as an extension, we have used voting classifier, which is an ensemble technique. So here we have used voting classifier that combines bagging with the random forest, AdaBoost with the decision tree, and XGBoost. So all these models have been combined in this voting classifier. So this helps the model to be more reliable and accurate in detecting the fraud. And here we have also added an explainable AI method, that is XAI techniques. So here we have used Lime and Chap so that we can actually see which features are influencing the prediction, making the system easier to understand and trust. So it shows the importance of each feature in prediction. And now moving on to the front end part. Here we have developed front end using a simple front end using Flask, where users can enter transaction details and they get predictions and they can get the predictions in right way. And here we have also added user authentication mechanism so that we can keep the data secure. So only authorized users can access the system while testing it. This way, the whole process is not just smart but also user friendly and safe. And to implement this project, we have followed the steps which are mentioned in the flow of work. So let us understand how we have implemented the project. First, we have imported all the necessary Python libraries and modules for data handling, machine learning, and model evaluation. Then we have loaded the dataset. After loading, we have analyzed it. So here the credit card transaction dataset is analyzed to understand its structure, features, and class distribution. Then comes pre-processing. So here the data is cleaned by removing null values, duplicate records, and outliers to ensure quality input for the models. In the next step, the synthetic minority oversampling technique, that is nothing but SMOT, is applied to balance the number of fraudulent and genuine transactions. Then comes feature selection part. So here the important features are selected using the method called select percentile, that is mutual info. So here we have used this method to improve the model efficiency and accuracy. Then comes building and training the model. So here various machine learning models are trained on the pre-processed dataset and balanced dataset. Then comes comparing the model. So here all the models which are trained are evaluated using accuracy, precision, recall, and FN scores. And those performance scores are visually represented through graphs. And we will be selecting the best performing model and saving it for the future use. Then comes feature interpretation, that is using explainable AI techniques, that is LIME and SHAP. Then coming to the front end part. So here a web interface is built using Flask, which includes user registration and login functionality that is supported by SQLite database. Then comes user gives input. So here in the front end, user will be able to provide input as feature values that will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us a prediction, predicting whether the transaction is fraudulent or non-fraudulent. So finally, outcome will be displayed through the front end of the application. And coming to the algorithms used, so these are the algorithms used in this project. So we have individually implemented DNN, that is deep neural network, logistic regression, support vector machine, XGBoost, random forest, KNN. So this is the first stage. And here we have developed a voting classifier, that is we have built voting classifier by combining XGBoost and KNN. Traditionally, we have also developed stacking classifier, which combines random forest with linear regression with support vector machine. And then the proposed system. This is the proposed model where we will be combining logistic regression, support vector machine, XGBoost, random forest, KNN, and deep neural network with a linear SVC. And we have also trained the model using this voting classifier. And now coming to the requirements of the project. To implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And in software, we need application of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them. So here in the model folder, we have the algorithm information that will be loaded into the project code during runtime. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. In this, we have the data set, sample file that we will be using in the front end. So this is the data set that we have used. So here are the different features. Based on these features only, we will be predicting the output. So here we have features named as V1, V10, V11, V12, etc. So the dataset features are anonymized to protect sensitive financial information, which is why many columns are labeled as V1, V2, V3, and so on. And here the last column which we have is the amount column. It is a feature that is actual transaction value. Even though the feature names are not descriptive, the model can still learn patterns in the data to differentiate between legitimate and fraudulent transaction. And this is the output variable, that is the target variable that we will be predicting in this project. And we will be training the dataset on this dataset. Let's close this. So here after pre-processing, it is stored in this file. And coming to this notebook file, so it is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So now copy the path from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. Here it is open. Just wait for a while. Now give the command cd, give the space and paste the copied path. Now click on enter. Here you can observe current directory is changed to the code folders path. So by giving the command cd and giving the path, directory will be changed to the current path. So now let's give the command python space app.py to compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link here, click on enter. This is the web page of the project, which is displayed in the browser. So you can observe, right? So this is developed using Flask framework. And we need to get started. So click on get started. To get started, first we need to create the account. If you have not created the account, first create the account and then sign in. I have already created, so I will directly sign in. Click on sign in. Give your username and the password. And now click on sign in. We have signed in successfully and redirected to prediction page of this project. So now click on go to prediction, or else you can click on this prediction tab. So here you can see multiple inputs that we can give. So here we have the parameters. So these are the most important parameters that are used for prediction, that impact the prediction. So after doing feature selection, these are the extracted parameters. Now let's open the test cases file. So open test cases, open the sample file. So here are the test cases. Let's apply filter to this target variable that we are predicting. Let's apply filter to class 0. Click on OK. So here let's check with this class, I mean this test case, where we are supposed to give the V1, that is minus 1.35, and then V2 is 2.53, V4 is 1.37, V14 is 0. That is minus 0.311. So here the next value is V18. So V18 is, so here copy the V18, that is 0.025, and then V28, that is minus 0.021. And the amount is 149.62. Enter the amount here. Now click on predict. So your given information, it will be pre-processed at the backend and then it will be fed to the trained, saved machine learning model. And that model will be giving us a prediction whether the given transaction is a fraud transaction or a genuine transaction. So just wait for a while. It is being, I mean, the process is being happened at the backend. So here we got the prediction. That is, the transaction is not fraud. So here the application is predicting that the transaction is not fraud. So this transaction is not fraud. Now let's check with this one. Click on predict again. Enter the V1 value, that is minus 0.425, and V3 is 1.141, and V4 is minus 0.168, V14 is minus 0.1371, and V18 is 0.0686, V28 is 0.081, amount is 3.67 rupees. Now click on predict. Here we got the prediction. So the transaction is not fraud. So this transaction is also not fraud. Now let's check with the other class, that is class 1. So apply filter to class 1. Click on predict again. Let's check with this case. So here enter the V1, that is 1.081. V3 is 0.8629. Enter V4 is 2.52. V14 is 0.3. V18 is minus 0.694, and V28 is 0.0105, and the amount is 1.52. Give it. Now click on predict. So just wait for a while. Here we got the prediction that the transaction is fraud. Here transaction is fraud. So this transaction is fraud. Now let's check with this transaction. Click on predict again. So here the V1 is 1.296, and V3 is 0.193, and V4 is 0.9016, V4 is minus 0.007, and V18 is minus 0.06, V28 is 0.020, and amount is 1.18. Click on predict. Here we got the prediction that the transaction is fraud. So in this way, just by giving input to the application will be predicting whether the given transaction is fraud or non-fraud. So here you can observe both the cases were working correctly. Now let's check with the graphs. For that, click on about. So here the first graph which we have is a sample outcome graph. Here on x-axis we have the classes that we are predicting, and on y-axis we have the count. 0 represents non-fraud and 1 represents very fraud. I mean, it's fraud. Here if you observe, 1 are very few. Here you can observe there are very few. That is why we have applied smooth technique to balance the data set so that model can learn better. And here we have balanced samples, sample distribution graph. So here on x-axis we have 0 and 1, and on y-axis we have count. So initially here if you observe one class, there were very few, which is a minority class. We consider it as minority class. So after doing data balancing, here you can observe the both count, I mean 0 and 1 value are both same. They are of equal count. So now model can learn equally. And here we have lime explanation. So this is the lime explanation of each variable. And here we have for SHAP explanation. It shows the feature importance. And here we have SHAP waterfall plot. So here we have accuracy score, comparison graph. Accuracy is a metric that is used to evaluate the models. So here in this graph, on x-axis, we have all the algorithms that we have trained. And on y-axis, we have their accuracy scores. And similarly, we have precision score, which is also an evaluation metric. This is the recall score. And here we have for FN score. And here, this is a sensitivity score. And here we have specificity score, MCC score. So these all scores are the metrics that are used to evaluate the model. Now click on logout. So this project tackles the growing challenge of credit card fraud by creating smart and adaptive detection system that learns from transaction patterns. So by combining multiple machine learning models with the explainable AI, an interactive interface is not only detects the fraud activity, but also makes the process transparent and easy to use for the applications. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.